Hey there, this is Cnix. Starting from this video, I will be talking about where you can use Cnix's DigitalTwin Pascal. No matter how great a tool is, if you don't have any use for it, it's pretty much useless, right? So in this video, we are going to tackle a multi-variables problem using Pascal. Getting started is always the hardest part. Especially when you have more than one variable, it can be really overwhelming to figure out where to even begin. That's where Cnix's DigitalTwin Pascal can step in and guide you. Alright then, in this video, let's dive into finding the optimal conditions for energy savings in a continuous manufacturing process when dealing with multiple variables. Let's get started. What you see here is a roll that you do typically find on a rolling line. For the sake of this demo, we are going to simplify things by only focusing on the roll's friction coefficient, the material thickness before rolling, and the material thickness after rolling. We will ignore all the other variables. Let's assume the roll's radius is 1 meter. If the rolled material can naturally fit itself between rolls without any external force, we wouldn't need extra energy to push it in. That means we could save on production energy, ultimately relating to carbon reduction, which is a big win. When machines are introduced, there are always necessary calculations for their movements. But man, those formulas can get super complicated. Just to take a look at this. Sure, you could manually plug in each value into these equations, but let's be real, it's not easy. It's definitely not something anyone can just jump into. And if a person does it, there's always a chance for human error. Not to mention, it's time-consuming. Plus, during testing, the production line can't be used for manufacturing, which is another hit. That's where digital twin can really make a difference. So from here on, let's use Cnix's digital twin, Pascal, to figure out the friction coefficient of the roll, along with the material thickness before and after rolling, to make sure the material can fit itself into the rolls without any extra external force. First, let's get the data ready to train the AI. I've already prepared it in advance. As you can see in this Excel file, you need to create a table with the input conditions and output values. For the output section, just fill it in using the formulas related to the machine's movement. Finally, save it as a tab separated text file. And that's it. You are all set with the training data for Pascal's AI. Pretty simple, right? For the training process, you can refer to the previous video. I will skip over it here. I've already done it beforehand. Alright, let's get the digital twin up and running. First, log into the Pascal server on the left tree menu. Select the project name 01 and then use the run process menu to start the new 01's digital twin. Once the digital twin is running properly, open an HMI that supports multiple TCP and start simulation. First, hit the Start Push button by individually adjusting the thickness of the material before and after rolling, as well as the roll's friction coefficient. You can find the conditions where the material can fit itself into the rolls without any extra external force. As you can see, the optimal condition is when the pushing force and the pulling force of the roll are balanced. This is the minimum requirement for the material to fit itself into the rolls naturally. At that point, the friction coefficient between the rows and materials, the input material thickness and the output material thickness are displayed as shown. When dealing with a multivariable system, finding the right process conditions for carbon reduction becomes so much easier with Pascal. In industrial environments, manufacturing equipment operates with countless variables, interacting with each other. As shown in this video, if you have a formula that describes machine movement, you can create and apply data accordingly. And if there are processes within the overall workflow, or even just parts of it, that can't be expressed through formulas, you can use data collected through Cnix's data service platform DAQ to generate the data needed to train the AI. Cnix's digital twin, Pascal, not only sharpens your insight and saves your time and money, but also helps with the carbon reduction. We will be back with another example in the next video. Thanks so much for watching.